Okay guys, good morning. Well, hopefully you are well, and I guess there are a few things that I wanted to clarify today. In the first part of the lecture, where there's a lot of things that we covered in the lecture, and I didn't get to demonstrate a lot on the differences between the override instructions. So I did give some well, textual differences between them. Okay, but I think a lot of the questions eventually came in and asked what are the difference between these instructions and whether there can be a nested equivalence or nested possibilities for all the override functions. So I'm just going to go through and work a little bit on explaining how these override functions is used. Okay, so I think the most or the easiest one to explain is the AND instructions. If you've programmed with using IDEs or integrated development engines such as Visual Studio or even MATLAB, you'll see that you usually have some kind of, you can put some kind of dots or breakpoints, okay, on the line of the program so that you can execute up to a certain point, and you can probably debug or search where are the errors, and or usually want to know how much processing time it takes, so usually put a breakpoints. Now you can do the same thing using AND instructions. If you look at this program, this is an example of a program where if I press PB2, you will end up lighting up L1 and also executing the timer, and eventually after 10 seconds L2 will turn on. Okay, so for example, you want to know whether or not your timer is working, but you don't want to turn on the output yet. Okay, if you look at your program, and you can see that this program have like symbol sections and end. So if you start a new program, say if you start any of the new program, okay, I'll just let's show you first. Okay, so and then you say pick CP1E, you eventually straight away have the AND instructions written automatically. So if I click this, I'll get AND instructions. Okay, so I'll just look at the AND demo again. Okay, so if I want, for example, to execute things so that I just wanted to look whether the timer works okay without eventually activating L2, I can copy the instructions or even just simply add end instructions here. So okay, and put AND instructions. Alright, so just write AND. So when you put the AND instructions here, you basically will execute only this rung and will end here and will not execute this. So let's simulate this and see what happens. Okay, so if I press PB2, okay, and we can see that the timer is running as well as the light is on. And when the timer is finished, the contact of it should activate, but you can see that the output is not turned on. Okay, so this basically means that when you have any instructions here, we will not execute any output at the next rung. Okay, so say that we want to move N further upwards and does not execute the timer. Okay, so if I okay, we will simulate this again. We will see that when we press PB2, eventually it will end here. It will not execute the timer at all. So end instructions basically work like a breakpoints. The breakpoints in the MATLAB, for example, you can have multiple breakpoints, put at each of the lines of program, and you can execute that in steps. So basically that sequential thing can be execute, or the part of the instructions in the middle can be executed independently from the rest. But in Omron PLC especially, you cannot do that with an instruction. So you kind of need another type of override instructions. So n instructions is the simplest kind of debugging opportunity. So you can execute up to whatever points, whatever rung the end is. So as long as there is n instructions there, you can omit the rest of the program. Okay, so then let's take a look at the slightly upper level, which is the interlock, okay, instructions. So when we take a look at the interlock instructions, and we know that with interlock, so shown here is nested, but say that for interlock instructions, okay, so if you for example right now, if you don't execute interlock at all, I set this on, it's not going to be executed. So interlock must always be on for the function to, for all the program to be executed. Okay, so now the problem with interlock is that well, not the problem, the way interlock works is that you can put any interlock in between, so it will actually be able to execute sections in the program as long as you are aware where is the outer interlock instructions. Say for example, you wanted to just execute the timer, okay, so you want to forget everything else, you want to execute the timer. So but the problem with interlock is that you cannot disable things outside the gate. So if you, for example, disable the outer ones, even both the inner and the ones that are outer of the set, or out of the inner programs, that is in between the outer interlock, will also be deactivated. So you cannot in isolation execute only the timer, for example, in this case, okay, have the inner interlock is turned on, the timer is not working, okay, simply because the outer ones are not on. So the problem is, if we turn this on, then basically L1 will also be on, whereas we don't want the L1 to be on, we just wanted this section to be on. So what are the workaround around this? Okay, so let's take a look at the jump. Okay, so previously on jump, okay, first of all, I have shown you in the class previously that there are one jump here. Okay, so the jump actually must be activated, not for the jump to not working. Okay, so this is counterintuitive. It's not like interlock. Interlock must be on for the execution of the rest of the instructions in between interlock IL and ILC, but the jump must not be activated for the jump to work, and must be activated for the jump to not work. Okay, so if you don't turn on this, okay, it means that we are jumping. Okay, so we see that the jump is here, all right, and then the end is here. So basically, if I turn on PB1, all right, it will skip the rest of this, and then only okay, and then only work to the end of the instructions. Okay, probably have to change a bit here because CR2 is supposed to be on, so I'm going to invert this and invert this one. Okay, so let's take a look again on what happened. So if I did not activate this, it means right now we are jumping. Okay, so if I set this on, you can see that even though CR2 is on, okay, CR1 is not activated, so we are jumping now. Okay, and since CR1 is not on, and obviously the lamp and the time and whatever here is not going to be working. Again, I repeat it again, that jump will only work if we disable the activation. So right now when you see activation here, it means right now we are not jumping, we are going to execute everything and kind of disregard what, that the line rung 2 and rung 10 actually exists. Okay, so by turning this activation, which means we are going to be able to run everything. Okay, so if I for example turn this on, we can see that the rest of the lines are operating. Okay, so this is obviously after some time lamp 2 will turn on. Okay, now you realize that when the program is running, okay, if you suddenly wanted to jump, you know, as the program is running and you set this one off, nothing is going to work. Okay, so you still stuck. The output is, it's not stuck, the output is still the same, because this is not like interlock. Interlock, once we turn that off, everything is reset. But with jump, it is not reset, it will stay that way, and the only way to reset is basically to turn off everything. Okay, so to turn off everything, so if I set this off, okay, I set this off, and then you can see it's still on there, and then you turn on the jump again. Okay, you turn on the jump again means you will execute everything after this, and the jump will not working. Okay, so this is an example to reset everything after the jump. So that's why it is important that the decision to make the jump or not to make the jump is done before you execute the main rung, or here in this case CR2. Okay, so for example, I wanted to jump. Okay, so I will disable this. So obviously right now I'm jumping, I will not be executing CR1 and obviously not the timer. So if I turn this on, then immediately it's not going to work. Okay, it's not going to work, and we have lamp 3 on. Lamp 2 will not be on forever because timer is not working. If we decided not to jump at this point, I press on. Okay, you can see the rest of this is working. You want to run the program as it is, that means you are activating PB5 beforehand. There is no way you can jump after you already gone through the cycle of the program. Alright, so this must be you must be able to grasp this, okay.